Dear students, welcome to the video double angle formula. We can use a compound angle formula in order to derive a double angle formula. Now, in the previous video, we learned that expansion of sine of a plus b is equal to sine of a cosine of b plus cosine of a sine of b. Now, let a is equal to b. Then on the left hand side it will be a plus a, which is sine of 2a is equal to sine of a cosine of a plus cosine of a sine of a. Now sine of 2a is equal to, these two are exactly the same, so it will be 2 sine a cosine a. It's another identity made for a double angle. Now, let's go for cosine of a plus b. Cosine of a plus b is cosine of a cosine of b minus sine a sine b. Now, again, suppose a and b are two equal angles, then we will have cosine of 2a, you can put brackets here, is equal to, it will be cosine of a, which is cosine squared of a, minus sine of a, which is sine squared of a. It is another identity made. Sine of 2a is 2 sine a cosine a. Cosine of 2a is cosine squared of a minus sine squared of a. Now let's go for tan. Again, tan of a plus b, the expansion is tan of a plus tan of b over 1 minus tan a tan b. Now let a and b are two equal angles, so on the left hand side we will have tan of 2a is equal to tan of a plus tan of a, which is 2 tan of a, then 1 minus tan of a times tan of a, which is tan squared of a. So it is the third identity which we derive here through compound angle expansions. There are a couple of identities can be derived using these identities, which are really important. Let's first find them. Now we just learned that cosine of 2a is equal to cosine squared of a minus sine squared of a. We learned in AS sine squared of a plus cosine squared of a is equal to 1. Now I replace sine squared of a by 1 minus cosine squared of a. So we have cosine squared of a minus, instead of sine squared I put 1 minus cosine squared of a. Left hand side is the same, cosine of 2a. So cosine of 2a will be here negative negative positive, so it will be 2 cosine squared of a minus 1. So if I transfer to the left hand side negative 1 and divide by 2, so cosine squared of a will be 1 plus 2 cosine of 2a over 2. This identity and the identity that I'm going to actually explain are really important identities, as specifically in integrations, because here cosine is in a quadratic form, and it is converted to linear form to the power of 1. So it is helpful in in integration to convert quadratic into linear. Power 2 here, cosine has a power of 1, so it will be really easy to integrate trigonometrical ratios of power 2. Now, for the next identity, I replace cosine squared by 1 minus sine squared. So cosine of 2a is equal to, now instead of cosine squared of a, I put 1 minus sine squared of a, then minus sine squared of a. So cosine of 2a will be 1 minus 2 sine squared of a. Now I replace, actually I transfer to the left hand side, minus 2, so I write 2 sine squared of a, it will be 1 minus cosine of 2a, then divide by 2, sine squared of a is equal to 1 minus cosine of 2a divided by 2. You can write them separately, like this, 1 over 2 minus 1 over 2 cosine of 2a. This is another important identity and useful identity, specifically for integrating functions involving cosine squared and sine squared. Now, first example for this video, given that sine of x is equal to negative 3 over 5 and x is between 180 and 270, means in the third quadrant, find the exact value of sine of 2x, cosine of 2x, tan of x over 2. First, let's use identities in order to find cosine and tan. So sine of x is negative 3 over 2, and we know that cosine squared of x is 1 minus sine squared of x. So it is 1 minus 9 over 25, so it will be 16 over 25. If you take a square root, so it will be positive negative 4 over 5, but as it is in the third quadrant and cosine depends on x, and x in the third quadrant is negative, so cosine of x will be negative 4 over 5. And we know that tan of x is sine of x over cosine of x. Sine of x is negative 3 over 5 over negative 4 over 5. So 5 cancel out, negative cancel out. It will be 3 over 4 is positive. We know that in the third quadrant both y and x are taking positive values, so that's why tan will be positive. Now, for part A, sine of 2x. Sine of 2x is 2 sine x. Cosine x will be 2 sine x negative 3 over 5. Cosine of x negative 4 over 5, which will be 24 over 25, positive actually. Part B, cosine of 2x, 2x, so it will be cosine squared of x minus sine squared of x. Cosine squared of x will be negative 4 over 5 squared minus sine, which is negative 3 over 5 squared, which will be 7 over 25 as the answer for part B. Now, for the third part, part C, tan of x is 3 over 4. We need it. 1 second. Let me again bring the question here. And I write here tan of x is equal to 3 over 4. We found in the previous part. So now tan of x over 2. So we should use identity involving tan so that x over 2 is involved. So tan of x actually can be written tan of x over 2 plus x over 2. X over 2x plus or plus x over 2 will be x. So we can use double angle formula. So it will be tan squared of x over 2, 2 tan of x over 2 over 1 minus tan squared of x over 2. So I write again, tan of x is equal to 2 tan of x over 2 over 1 minus tan squared of x over 2. Now, tan of x is 3 over 4 is equal to 2 tan of x over 2, 1 minus tan squared of x over 2. Now, to avoid overwriting, let tan of x over 2 be, for example, t. So it will be 3 over 4 will be 2t minus over 1 minus t squared. I do cross multiplication. It will be 3 minus 3t squared is equal to 8t. So I write to the right hand side. It will be 3 t squared plus 8t minus 3 is equal to 0. So if you factorize, it will be 3t minus 1 times t plus 3 is equal to 0. So once t is equal to 1 over 3 and t is equal to negative 3. So here t I replace again t by not t is tan of x over 2. So tan of x over 2 will be 1 over 3 and tan of x over 2 is equal to negative 3. Now again I use substitution. Let x over 2 be, for example, y. Tan of y is equal to 1 over 3. Then tan of y is equal to negative 3. Then we take tan inverse. So y will be then tan inverse of 1 over 3 and y will be tan inverse of actually we are not supposed to find x over 2, so there is no need to take these steps because angle is not asked. So we are supposed to find tan of x over 2. So let me erase them. Erase this part. Okay, so tan of x over 2 is 1 over 3 or negative 3. But which one will be correct? We know that x is in the third quadrant. X is between 270. Let me change the color here. So x is between 270 and 180. So it is x over 2. So x over 2 I divide all by 2. It will be between 90 and 135. It means that x over 2 is in the second quadrant. In the second quadrant, tan is negative. So in the second quadrant, tan is less than 0. So this will be the acceptable answer. So tan of x over 2 will be negative 3. Negative 3 will be the acceptable answer actually. Now, next example, solve the equation sine of 2x is equal to sine of x. So you have a double angle here. So I write 2 sine of x cosine of x is equal to sine of x. So I transfer to the left hand side and factor sine of x. So it will be 2 cosine of x. Then minus 1 is equal to 0. So 1 sine of x is equal to 0. 1 cosine of x is equal to 1 over 2 if you solve this equation and this equation. So if sine of x is equal to 0, then actually we need to use actually formula and techniques in order to solve these basic trigonometric equations. We take sine inverse and it should be in the between 0 and 360. So x will be sine inverse of 0 which is 0 actually. Then it is acceptable. Then 180 minus 0 is another answer. So 180 minus 0 is another answer which is acceptable. 0 plus 360. 0 minus 360 0 plus 360 is acceptable, so 360 is the other answer. Minus will be negative, so 180 plus 360 negative 360 doesn't give you. So these are the three answers you get here. But for the second one, cosine of x is equal to 1 over 2. So x will be cosine inverse of 1 over 2, which is 60 degree. Then negative 60 is the other answer, which is not acceptable. But now x plus 360 is not acceptable, x minus 360 is not acceptable, minus 60 plus 360, yes, which is 300, acceptable. Minus 60 minus 360 won't be acceptable. So overall in ascending order, 0, then 60, then 180, then 300, and 360 are the acceptable answers. Now next example, cosine of 2x plus 3 sine of x is equal to 2. So if you remember, here we have two different ratios, cosine and sine, in the same equation. So here you have cosine of 2x. If you remember, cosine of 2x can be written as 1 minus 2 sine squared of x. So I replace it by 1 minus 2 sine squared of x plus 3 sine of x is equal to 2. It is sine. Now I transfer is equal to 2. So I transfer all to the right hand side. It will be 2 sine squared of x plus actually minus 3 sine of x, 2 minus 1, which is plus 1 is equal to 0. So if you factorize, it will be 2 sine of x minus 1 sine of x plus 1 is equal to 0. Then sine of x is equal to half. Sine of x is equal to negative 1. And the angle is should be expressed in radians between 0 to 2 pi. So if you take sine inverse of 1 over 2, so x will be pi over 6, and sine inverse of negative 1, x here, let me check again, it is positive 1, so it should be negative, sorry, yes, then, so it will be then positive 1. So if you take sine inverse of 1, so x will be pi over 2. Then pi minus pi over 6 is the other answer. Pi for this equation, let me write it here. Pi minus pi over 6, which is 5 pi over 6, acceptable. Then here the other answer will be pi minus pi over 2, which is again pi over 2, doesn't give you new answer. But plus 2 pi minus 2 pi, plus 2 pi minus 2 pi won't give you acceptable answers here as well. Plus 2 pi minus 2 pi as well. So overall answers are pi over 6, pi over 2, and 5 pi over 6 as the acceptable answers. Thanks for watching this video.